Hello friends, welcome back to my channel Dr. Vijay SSOC. Today in this video, we are going to solve a problem from Pavia Spectroscopy book, page number 552, and the problem number is 1 as you can see here. In this problem, they have given us DEPT-135 COSY NMR head-core spectra, and we have to assign the protons and carbon for this molecule having molecular formula C4H9Cl. So through this problem, we are going to learn about DEPT-135, how to interpret COSY NMR, and how to interpret head core. Head core is also known as HSQC NMR. So these 2D NMR techniques are very important for solving the complex structure of the organic compounds. So therefore, it is very important to learn these two-dimensional NMR techniques. So let's start this video. So first, we have to understand that what is the unsaturation, or we can say index of hydrogen deficiency in this molecule. So let's say so the formula is 2C plus 2 plus number of nitrogen minus number of hydrogens minus number of halogens divided by 2. So what will be the answer? 2 multiplied by 4 plus 2, 0 nitrogen, 9 hydrogen minus 1 halogen. So it is 10 minus 10, so it's 0. So this molecule does not have any unsaturation. No unsaturation. Now we have to see the DEPT-135 NMR. What is DEPT-135 NMR? In DEPT-135 NMR, you can see the signal for all the carbons having at least one hydrogen. So for the methyl signal, you will see the signal in the positive phase, and for CH as well. So this is the positive phase, and for the negative phase, you will see the signal for CH2. These things I have already explained in my previous video. Okay, so now there are how many signals? There are 4 signals, right? 1, 2, 3, and 4. So it is matching to the molecular formula because there are 4 carbons as well. Now this is for sure attached to the CH2. So the molecule has one CH2 group. This one probably CH3 because this is in the shielded region, right? What is the ppm? Let's say maybe around 15 ppm, right? So it is for sure it is correspond to the methyl. Now there are 2 signals. This one could be CH, and this could be also CH, or this one can be CH3 also, right? This is also deshielded, but around 60 ppm, this one for sure it is belongs to the CH. I am 100% sure because it is highly deshielded, so it cannot be methyl signal in the uh, ppm around 60. On this just basis of the DEPT-135, I can easily assign the structure of this compound. So let's try to assign the structure of this compound. So one is CH3, and then it has CH2. After that, around 60 ppm, it has CH. So probably this one is attached to the chloro, and then it has another methyl group. This is the only one possibility. Now you can say that no, there is another possibility also. What is that another possibility? Another possibility, you can say that this molecule you can write like this: CH3, CH, CH3, chloro, and this one. So if you write this molecule like this, then how many CH3 you should have? You should have 3 CH3 and 1 quaternary carbon. So this is not possible, right? Now another possibility is CH2, then you can attach chloro, CH2, CH2, then CH3. So in this case, you will have 3 CH2, right? And how many CH2 you are seeing in the depth NMR? Only one CH2. So this possibility is also not possible. So what I am trying to say, the compound with the molecular formula has this structure. This is for, I am 100% sure, this is the correct structure for the given problem. But this is not our aim. Our aim is to assign the signal to each carbon and protons. So on the basis of chemical shift knowledge, you can easily assign that this is the first signal. If you go back, this is the first. The second would be this carbon. Then third one is around 60 ppm. So this is the third signal, and this is the fourth one. This I can assign on the basis of my chemical shift knowledge. But we have to use two-dimensional COSY and HSQC spectra. So let's go to the COSY NMR. So this is COSY NMR. In my previous video, I have already explained in a detail how to interpret COSY NMR and what is the significance of diagonal peaks. These are the diagonal peaks and cross peaks. The peaks which are appearing on the other side like these are the cross peaks. So what is the significance of these peaks? I have already explained in my previous video. You can watch for better understanding of COSY NMR. Okay, so this is the diagonal. This line, you can draw the diagonal like this. And this first half of this diagonal and the second half of the diagonal are mirror images of each other. We can say that this is like a mirror image of each other. So first we have to look the diagonal peaks. As you can see that, let's label the diagonal peaks. For example, this is proton 1, this is 2, this is 3, this is 4. And here is also proton 1, 2, 3, 4. And we know that in COSY NMR, both the axes, this is x-axis and y-axis, have 1H NMR. Now, diagonal peaks represent the chemical shift value. As you can see that this diagonal peak first corresponding to this one, right? So how many diagonal peaks would be there? Of course, 4, right? So this is the first diagonal peak, this is the second diagonal peak, this is the third diagonal peak, and this is the fourth diagonal peak, right? Because there are 4 protons, 4 types of protons. Let me draw the chemical structure of this molecule also. Okay, this is the chemical structure. Now I can see that this methyl will be triplet, right? Because of the CH2 splitting. But this methyl will show doublet due to this hydrogen, because we know that splitting pattern follow n+1 rule. So you can see that this is the triplet, this is the doublet. So this is belongs to these 2 protons. But now we have 2 multiplates at 3 and 4. This is multiplates. We don't know which multiplates belongs to which carbon. Now this one is left and this one is left, right? This is multiplate, this is also multiplate. Okay, so how we solve the COSY NMR? Take diagonal peaks. Let's say first one we are taking, draw the vertical line and see, is it connecting to any dots? Yes, it is connecting to this dot. This is the cross peak. Now draw the, this was first we draw the horizontal line, now draw the vertical line. Okay, so this is the vertical line. So you can see that the proton 1 is interacting with the proton 3. What does it mean? So proton 1 is interacting with the proton 3. This means that they are vicinal protons. Vicinal protons. So they are in a close proximity. Vicinal protons. This triplet is close to this one. So it means this is the third one. So I can say that this is the proton first. This is the proton third. Am I right? Now, as I explained you in my previous video, this cross peak 1,3 cross peak is real or not, you can find in a very simple way. Just draw another vertical line and see if you are seeing the another cross peak. Yes, I am seeing the another cross peak and it is making the square. This is the square. If you are seeing the formation of the square, then it is the real cross peak. Okay, now we found the 1,3 interaction. Let's look the peak, diagonal peak 2. This is the diagonal peak 2. And now draw the horizontal line and see if it is connecting to any peak. Yes, this diagonal line is connecting to this one, right? I can put the right mark so that you can see this one. And now I'm going to draw the vertical line. This is the vertical line I'm drawing. This is the vertical line and it is connecting to 4. So 2 is showing the interaction with the 4. So what does it mean? 2. So 2 is in close proximity to the 4. So they are vicinal protons. And 2 is doublet. This is the doublet and it is in close proximity to the 4. So it means the 4 is this one. This is the multiplate. This multiplate, yes. So this is 2 and 4. So I can say that this one belongs to the 4th proton and this one is 2, right? So you can see that I managed to assign all the protons. Now here also you can find the off diagonal peaks on the other side of the diagonal, and if you connect you can make another square. So this is the another cross peak. Now let's look at the third diagonal peak. This is the third one. Draw the horizontal line and you can see that this is connecting to this 3. Yes, 3. And then draw the vertical line. It is connecting to here. So you can see that 3, this is the 3, is showing the interaction with 4. So 3 proton is showing the interaction with the 4 and it is here. It is here. You can see that this is the 3 and this is the 4, right? So we have found all the interactions and you can connect to make a square also. Okay, I'm going to draw the 3 to line this one. Okay, this is the another square, formation of the another square. Okay, so we have assigned all the protons very nicely, right? So this one, you can see that this methyl is 1, this is 3, this is 4, and this is 2. Okay, let me draw the structure on the other side. So what I am saying, we have this molecule and we managed to assign the protons to this molecule. This one was 1, this one was 3, this one was 2, and this one was 4, right? Yes. So this is 1, 2, 3, 4. So one is CH3 attached to CH2. This 2 is CH3 attached to CH, and this third one is CH2 attached to CH3, and this fourth is CH attached to chloro. Now we have HSQC NMR. This is HSQC NMR. In HSQC NMR, you see the interaction between carbon 13 and 1H proton, which are directly attached. This is important to remember, directly attached. So this carbon will show the interaction with this hydrogen through J1. Yeah, it is called single bond coupling. Yes, single bond. Okay, you are not going to see the interaction of the hydrogen with the neighboring carbon. No. So you must see the carbon 1 should show the interaction with the methyl hydrogen, right? Okay, now you have to find the cross peak. There is a cross peak, right? So what you have to do, draw the vertical line like this, and then horizontal line like this, and see where it is connecting. So this vertical line is connecting to methyl proton, right? So we can say that this peak is belong to the carbon number 1. Am I right? Yes, this peak is belongs to the carbon 1 because it is connected to the methyl. Now there is a second dot. Again, you can see this vertical line is connecting to this carbon, and horizontal line is connecting to this carbon. Sorry, this proton. So this is showing that this is the CH3. CH3 is connected with the, okay, this is the second methyl. Okay, this is the carbon, this is this second carbon, because you can see that it is connecting to the doublet. This is doublet, this is the triplet, and this was the multiplet and multiplet. Now we have third peak, and you can easily find it belongs to which carbon. So this third peak is connecting to okay, so this one is the third carbon, right? Because this multiplates is showing the interaction cross peak with this carbon, so for sure this is the third carbon. And now assignment of the fourth carbon is left. So this one, the peak, if you see, there is a dot, cross peak, and you can draw the vertical line as we did for the previous one, and horizontal line. So it is connecting to fourth, right? Fourth type of proton. So we can say that this is the fourth carbon. This one is the fourth carbon. So now we have assigned all the carbons. This is carbon number 1, 2. This signal belongs to the 3 carbon. This is 4th carbon, and we have used the same label for the proton also, right? This is the proton 1 type. This is the proton 2 type. This is 3 type. This is the 4th. So we have assigned the proton and the carbon to this molecule very nicely, and I hope that it is clear crystal to you how to interpret the COSY NMR and how to interpret the HSQC NMR. And if you have still any doubt about the COSY or HSQC, you can write me in the comment box. I can make another video with another example. So don't forget to subscribe my channel. We will see you in the next video. Thank you very much. Take care. Bye bye.